of these tasks, and we are group 1.8, and our task is to develop a C++ programming for motor current safety monitoring system. A general overview of this project is a motor current safety monitoring system is a C++ application developed to monitor the operating current of electric motors. It compares the measured current with the rated current to determine whether a motor is operating safely or is overloaded. The system accepts motor details, validates user inputs, calculates the current differences, displays the motor status, and generates a report that is saved to a file. It demonstrates the use of object-oriented programming concepts such as classes, objects, functions, loops, conditional statements, and file handling. I'm Edward, and also the pseudocode writer. The pseudocode provides a simple step-by-step description of how the motor current safety monitoring system works before it is implemented in C++. We start by accepting the number of motors to be monitored, uh, then collect the motor name, rated current, and measured current. The system validates the input, calculate the current difference, and compares the measured current with the rated current. It, if the measured current is less than or equal to the rated current, the motor is classified as operating safely. Otherwise, it is flashed with an overload warning. The process repeats for all motors, after which the program displays and
My
saves.
name is Wisdom Tetemate, and I'll be presenting on the algorithm. An algorithm is the step-by-step process or instruction we follow to solve a specific program. So in this case, this is the algorithm for the motor current safety monitoring system. 1. Start the program. 2. Display the project title. In this case, the motor current safety monitoring system. 3. Ask the user to enter the number of motor to be
Hello,
checked.
my name is Jonathan Daniel. I'm the flowchart lead. And then you see with the flowchart, we are supposed to start with the start, that is to execute the program. So every flowchart must have a start. And then from there, you go to display project title motor current safety monitoring system. That is what the computer is supposed to display. Okay, from that, then you go to input number of motors, right? It's used to define the total number of motors being evaluated. Then you go to the initialize save
I'm
count is
Samuel,
equal to
the C++ programmer, and I'm going to walk you through dot, the main.cpp. That is the file that controls the center of our motor current safety monitoring system. We start by including the necessary libraries for our input, output, the file handling, the strings, and input validation. And then we create a variable called motor. The object will be used throughout the program. And also you can see that we use the do while. We use the do while loop to keep the application running until the user chooses to exit. Inside this loop, we can see a switch statement. It displays the menu and executes the selected option. In case 1 is a
Hello
for
everyone,
loop
my name is
and
Gambodu and I am the testing lead for my group. So first off, you need to compile and run the code. After compiling and running the code, these are the options that will be available. So I'll be choosing monitor motors. So after inputting monitor motors, they will be asking the number of motors I'll be using, and I'll be choosing 2. And after choosing 2, I'll be entering the name of my this one. So I'll be using pump. For my rated current, I'll be using 6 amperes, and for my measured current, I'll be using 5 amperes. After that, you can see that my difference is what? -1 ampere, meaning the status is safe operation. If it's so, I'll be using the second motor for an example of a different operation. So I'll be repeating my rated current, which is 6 amperes, and I'll also be repeating my measured current, which is 7 amperes. So my current difference here is going to be 1 ampere, meaning the status is what? Overloaded.
Hello everyone, my name is John and I serve as the GitHub manager for our project. My responsibility was to create and manage our GitHub repository, upload the project files, and ensure that all updates were properly organized. GitHub also helps us to track everyone's contribution, making it easy to see who worked on different parts of this project. The contributors you see here are the team members who actively
Everyone, my name is Baji Maxwell, and my role in this project was documentation. I documented the entire project from the start to the end. This includes writing the problem statement, the pseudocode, and the flowchart to solve the problem's logics before coding. After that, I documented the C++ program, carry out model testing to verify that each part worked correctly, and recorded the testing. This documentation ensures the project is well organized, easy to understand, and can be